What if humanity had to live on Pluto? Imagine this. Humanity has decided to settle at the very edge of the solar system, where the sun looks like a bright distant star, and its light reaches Pluto's surface only after 5.5 hours of travel. Life here seems impossible: brutal cold, tiny gravity, and endless frozen deserts. But what if we tried to make this dwarf planet our new home? Why this could happen? There could be several reasons. In the future, humankind might exhaust the resources of Earth and the nearby planets. Or Pluto could become a crucial outpost for interstellar travel. It lies on the border of the Kuiper Belt, where deep space begins. Another reason could be scientific. A colony on Pluto would offer a unique opportunity to study the farthest reaches of the solar system. Before we continue our journey through the unknown, take a moment to like this video and subscribe to join our growing crew of space survivors. Comment below, where should humanity try to survive next? A frozen moon? A drifting comet? Or something even stranger? Pluto's environment. Life here would indeed be difficult. The average temperature is about -230 degrees Celsius. The atmosphere is extremely thin, made mostly of nitrogen with traces of methane and carbon monoxide. Gravity is 6 times weaker than on Earth. A person weighing 70 kilograms on Earth would weigh only about 5 kilograms here. The length of a day is almost the same as on Earth, 6.4 Earth days, since Pluto is tidally locked, always showing one side to its moon, Charon. Resources for survival. Pluto's most valuable resource is its ice. It contains not only water but also nitrogen and methane. Water could be melted and split by electrolysis into oxygen and hydrogen. Methane could be used as fuel. Nitrogen could serve to create an artificial atmosphere inside domes. In this way, even under such harsh conditions, the basic needs of a colony could be met. Sources of energy. Solar energy here is almost useless. The sun is far too distant. The main sources would be nuclear and thermonuclear power. Reactors could run on imported uranium or plutonium, and in the future even on helium-3 extracted from the icy bodies of the Kuiper Belt. Additionally, geothermal heat could be used if warm subsurface oceans exist, as some scientific models suggest. Survival technologies. The first settlers would have to live beneath transparent domes, made of strong composite materials capable of withstanding extremely low temperatures and radiation. Inside these domes, an artificial atmosphere of oxygen and nitrogen, extracted from local resources, would be maintained. To preserve heat, multi-layer thermal insulation and constant heating from nuclear reactors would be used. Living modules could be partially buried beneath the surface to protect against cosmic radiation and drastic temperature changes. Food supply. There are no natural food sources on Pluto, so the colony would depend entirely on artificial agriculture. Inside the domes, hydroponic farms could grow vegetables and grains. For protein, bioreactors would cultivate meat cells or algae. Carbon for crops could be obtained from methane, and nitrogen from the local ice. Over time, the colony could become nearly self-sufficient in food production. Transportation and communication. Because of the weak gravity, moving across Pluto's surface would feel like traveling in slow-motion flight. Lightweight all-terrain vehicles powered by methane fuel or electric systems would provide mobility. For exploring the icy plains, robotic drones capable of drilling into frozen layers would be used. Communication with Earth would have a delay of several hours. The signal travels more than 4.5 billion kilometers. This means the colony would need to operate with a high level of autonomy. Society. The first colonists on Pluto would be pioneers of a new world. The colony would consist of several hundred people: engineers, doctors, agronomists, scientists. They would live in a community where discipline and cooperation were matters of survival. Because of isolation, psychological support and clear social organization would be crucial. Over time, if conditions allowed, the population could grow to a few thousand, forming a true settlement on the edge of the solar system. Advantages of living on Pluto. Despite its harshness, Pluto has its advantages. Its vast ice reserves are a huge source of water, oxygen, and fuel. Low gravity makes it easier to launch spacecraft, turning Pluto into an ideal base for missions into the Kuiper Belt and beyond, toward the stars. Its thin atmosphere could still help shield against cosmic micrometeoroids. And with its mysterious geology and possible subsurface oceans, Pluto would be a true paradise for scientists. Threats and risks. Pluto is a place where nature is almost hostile to life. The temperature of -230 degrees Celsius instantly freezes any unprotected equipment. The atmosphere is so thin that a human could not survive even a single minute without a spacesuit. Cosmic and solar radiation can severely damage human cells. Another danger lies in geological instability. The icy surface shifts and cracks, and ice volcanoes may erupt, releasing nitrogen gas. How science could solve these problems? To survive in such conditions, the colony would rely on multiple layers of protection. Against the cold, multi-layer thermal barriers and internal heating systems. Against radiation, parts of the living modules would be located beneath thick ice, which effectively absorbs radiation. Against ground instability, buildings would stand on movable platforms or special pile-based structures capable of adapting to the slow movement of the ice. These technologies would make life difficult, yet still possible. Simulation of colony life. Inside the domes, life would resemble that of a small city, housing blocks, farms, laboratories, recreation zones. Because of the extremely long days and nights, the colony would follow an artificial light schedule to preserve a natural circadian rhythm. People would work in shifts, some on the farms, others in energy centers, and others conducting scientific research. Free time would be spent in communal halls equipped with holographic systems that recreate Earth's landscapes. Psychological support would be as vital as technical maintenance. Interaction with Earth and other colonies. Communication with Earth would have a delay of several hours, meaning instant conversation would be impossible. The colony would need to operate almost entirely autonomously. Supply missions would be rare, perhaps once every few years. Therefore, the Plutonian base would depend heavily on its own resources. In return, it could serve as a transit hub for expeditions heading into the Kuiper Belt, a place to repair ships, refuel them, and send them farther into deep space. Long-term prospects. In the long run, Pluto could become the true capital of the outer frontier of the solar system. Over time, the population might grow, and the domes could evolve into vast enclosed cities. The colony would become a center of resource extraction, scientific research, and the launching ground for humanity's first interstellar mission. And although life here would never be easy, Pluto might one day become the key that opens humanity's path beyond our own star system. Possible discoveries. The colonists could make revolutionary discoveries. Beneath Pluto's thick crust of ice, some hypotheses suggest the presence of a subsurface ocean. If it truly exists, it could become a unique laboratory for the search for life, even primitive forms. Studying Pluto's geology would help scientists understand how icy worlds form at the edge of the solar system, while the discovery of new elements or rare isotopes could have enormous implications for science and technology. Moral and psychological aspects. Life on Pluto would mean isolation, remoteness, and an eternal winter. People would have to struggle with loneliness, since Earth would appear only as a tiny star in the distant sky. Psychologists and specialized support programs would play a vital role. Virtual reality systems would recreate forests, seas, and cities so that colonists would not forget what life on Earth feels like. A sense of unity and shared purpose, that is what could keep them together in such a hostile world. A fantastic but logical scenario of development. Imagine that 100 years after the colony's founding, Pluto has become a scientific and industrial hub. Under its domes stand entire cities, while beneath the surface lie vast underground complexes. Here, fuel is produced from methane, food is grown inside enormous agricultural domes, and expeditions are launched even farther, into the Kuiper Belt and toward interstellar space. Pluto becomes the gateway to the universe. Conclusion: Is survival possible? From a scientific perspective, life on Pluto is possible, but extremely difficult. Humanity could survive thanks to technology, nuclear energy, sealed domes, hydroponic farms, and the use of local ice resources. It would not be a comfortable existence, but rather a daily struggle for survival. Yet it is precisely such challenges that have always driven humankind forward. Final note. Thus, Pluto may become not only a distant and frozen world but also a new home for those brave enough to challenge the cosmos itself. And now imagine, what if humanity had to live not on Pluto, but in the very heart of a comet traveling through the solar system?